Yeah, so good evening everyone. Good evening. Yeah, so this is the thing what we discussed yesterday. This is the thing, right? So let's see one by one. So this right yesterday discrete mathematics is started, right, with the logic, right? Mathematical logic is the first chapter. We started this. Afterwards, we will see the remaining chapters. In the logic, we started right. Logic contain two parts: propositional logic and right first order logic, proposition logic and first order logic. So we are discussing now first order logic, sorry, propositional logic we started. So what is the proposition? I already explained. A statement which is either true or false but not both is known as a proposition. A statement which is either true or false but not both is known as a proposition. So some examples also I given, right? Yesterday we discussed also. Next one. Let us assume P and Q are two propositions. Then P R Q, P and Q, negation P, P implies Q, P double implies Q. These are known as compound propositions, right? So P and Q are simple propositions, right? If you use any any operator, or if you use more than one simple proposition, it is going to be a compound proposition. That also we discussed. Then afterwards, we started drawing the truth tables. So PQ, so PRQ, P and Q, negation P, negation Q, P implies Q, Q implies P, negation P, RQ, P double, right? P double implies Q, 1 and 2. So many things we constructed. Now, if you observe clearly, everyone observe. P there, negation P there, negation Q also there. P R Q I done, right? P and Q also I done. P implies Q done, Q implies P done, negation P, negation Q, everything done. So if you observe clearly, right? If you observe clearly here, so see the table. What is the meaning of right? If anyone having small doubt, just I want to ask, what is the meaning of R operator? PRQ means at least one true there true. At least one true there true. See, at least one true, so true. At least one true, true. At least one true, true. Right? At least one true, no, not there. So what is the meaning of P and Q? Both should be true. Both are true, true, otherwise fail. Everyone know. Negation P, whatever P, reverse of it. P true means negation P is false. P true means negation P is false, like that. Next one. Q true means negation Q is right, false. Q true, negation Q is false. So like that. So, but understand here everyone, and everyone try to understand here. Everyone try to understand it. In the truth table, right? So suppose in that a particular compound statement, this is the right, this statement, this compound statement truth table is this. This compound statement truth table is this, right? This compound statement truth table is this. Remember, in any truth table, all are true. You know very well that is going to be tautology. All true means tautology. You know this very well. See, all true tautology. We discussed already in the yesterday's class. In a truth table for a compound proposition or for a proposition, all are true tautology. All are false contradiction. All are false contradiction. We discussed already in the yesterday's class. We are already discussed in the yesterday's class we are already discussed. Suppose some people are saying if all true there in a particular for a particular proposition in the truth table, all are true tautology, all are false contradiction. So but if you observe clearly here, so here all are not true, here all are not false also. These two are see, all false. Where is all false? I think here, see, here all false contradiction. Here all true? No. Neither all true nor all false. Neither tautology nor contradiction. Remember, that is called contingency. Contingency means neither true nor neither tautology nor contradiction. That is called contingency. Right? So I think if you observe clearly, at anywhere all true there, check. All true tautology. At anywhere all true, series one. P R negation P. All true. See. P or negation P, all true. All true. So all true, that is a tautology. And one more thing, at least one true. At least one true. See, here at least one true there. 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 So at least one true, satisfiable. All true, tautology. All false, contradiction. Neither tautology nor contradiction. That is called contingency. You know very well, in the last class we discussed it also. Right? See this one. At least one true, satisfiable. Neither tautology nor contradiction, contingency. Every tautology, if you observe clearly, every tautology is every tautology and contingency is satisfiable. Exactly. Every tautology, every contingency, right, is a satisfiable. Every contradiction is not satisfiable. Every contradiction is not satisfiable. Next one, every satisfiable need not be tautology. Right? If you want, you can write the seventh statement. Every satisfiable need not be tautology. Every satisfiable need not be tautology. Try to understand. Every satisfiable need not be tautology. I hope everyone is clear with this. Every satisfiable need not be tautology. These things we are already covered. Now come to the major one. Today's class major. Today's class very, very important one. Everyone try to understand. Today's class very, very important. P implies Q will be written as. P implies Q will be written as. Right? So one is going to be, right, negation P or negation Q. P implies Q will be written as negation P or Q. That is okay. One more thing is, right, reverse these two people, keep negation. This is called contrapositive. Right? If you reverse it, that is called converse. If you do the negation only, that is called inverse. If you do both, that is called contrapositive. So right? Remember, P implies Q means negation P or Q. One more is, first reverse it, keep negation, contrapositive. That is also equal. Next one, this can be written as if P then Q. That is also okay. This can also be written as answer is Q if P. From the P, Q is coming. Means Q is the result. Answer is result is Q if P. Right? Next one, Q will happen whenever P. Q is the answer whenever P. Next one, Q came from P. Q follows from P. Next one, Q is the consequent of P. Remember, in the P implies Q, Q is the consequent of P. That is okay. But remember, right? And one more thing, consequent, it is called antecedent. So Q is called as a consequent, P is called as antecedent. P is called as antecedent of Q. Q is the consequent of P. P is the antecedent of Q. Next one, P is a sufficient condition for Q, but Q is the necessary condition. These are very, very important things. Try to understand. These are very, very important things. P is the sufficient condition. P true or false, it's okay. That is the reason it is a sufficient condition. But Q necessary. Why Q necessary? If P true, Q should be true. Otherwise, it will become false. Q is the necessary condition, but P is the sufficient condition. Next one. This is also called as a P implies Q. P implies Q. But I think 12th one is going to be little tricky. Can you see the 12th one? 12th one is going to be little tricky. Actually, Q. So if you see this one, Q if P. But if at all, if P also, you can let's see P if Q, that is okay. But only if, remember, it is not if. Only if means fail. See, I'm repeating again. If you write only if here, then 12th one is fail. Only if correct. If you write if, 12th one is fail. Only if is going to be correct. The meaning of this one is P can only be true if Q true. Right? The meaning of this one is P can only be true if Q true. So whether you get this line or not doesn't matter. This one is a very, very important one. Please remember this. So the meaning of this one is going to be, see this one, the meaning of this one is going to be, if P true, Q should also be true. Indirectly, directly, that is a meaning. If P true, Q should also be true. That is the meaning of that line. P, right? So Q1, right? Q should be true if P true. That is the meaning of this one. Q should be true if P true. That is the meaning of the 12th line. So fourth line, 12th line, fourth line, 12th line, please take care. Remaining all are normal. Fourth line, 12th line, please take care. Remaining all are normal. It's a very normal thing. It's a very normal thing. Fourth one and 12th one, very normal thing. Very normal thing. Fourth one, 12th one is very normal one. There is nothing difference, but I think slightly different. Q is the result if P. Another way of saying that, right? Q should be true. Q should be true if P is true. If P is true. Q only be true if P is true. Q only be true if P is true. So remember 12th one, 4th one, remember. Other than this, nothing is there. This is the very, very important one. P implies Q is true. P implies Q is true. Right? So answer is going to be Q true if P true. Next one, P only Q. What is the meaning of this one? See, P can only be true if Q is true. P can only be true if Q is true. So careful. It's confusing, I know, but right, my request is, instead of doing that much research, so fourth one, 12th one, please take care. Fourth point and 12th point, take care. Do you have any objection till now? Do you have any objection till now? Yeah, good evening. Thank you. Yes, Lepakshi. Yeah, good evening, Lepakshi. Good evening, everyone. So yesterday we done until here. So we have to do some problems today. So let's go to first problem. This is the first problem of today's class. In my opinion, today's class is just started now. What is the converse of the following statement? So some people are asking, what is the converse? What is the inverse? I will explain one more time for you. Can you see this one? In this table, if you observe, right? In this table, if you observe, I said the tautology, all the things I said. But if you observe clearly in this table, 1 and 3, both are same. Check. Remember, if two truth tables are equal, then I can say those two are equal. If we check the 1 and 3 in this table, if you check 1 and 3, both are equal. If two truth tables are equal, try to understand. If two truth tables are equal, then I can say that those two equations are equal. 1 and 3 are equal. Remember, suppose 1 and 2 are not equal. Say truth tables are not equal. Check. Right? 1 and 2 is not correct, not equal. But 1 and 3 is correct. And if you observe clearly, see the fourth one. One time. See the fourth one and see the fifth one. What is the fifth one? 1 also and 2 also, end operation. So remember, P implies Q and Q implies P. If you do, you got the fifth one. Fourth one, fifth one equal. Check. When can I say double implies is true? If both are same, true. See, P and Q both are same. If both are same, then P and Q, P double implies Q is going to be true. P double implies Q is nothing but, right? P implies Q, end operation, Q implies P. Right? I think you are perfect. So I written one by one. Can you see this one? Everyone observe. P implies Q, converse is, just reverse it. But remember, they both are not equal. Converse is going to be Q implies P. P implies Q, right? Just keep the negation. Inverse is same, just keep negation. But remember, they both are not equal. P implies Q, first to do converse, then keep the negation. P implies Q, first do the converse, then do negation. It's going to be contrapositive. It's going to be contrapositive, but remember these two are equal. These two are equal. These two are equal, remember. And one more thing is, remember, negation Q, right, implies negation P. So this can be written as, right, I think if you see the statement, you can write like this, right, Q R negation P. This can be written as, right, so it's going to be, if you observe clearly, right, this is going to be negation P R Q, which is nothing but P implies Q. So if you do this one, right, same thing. So what I mean to say is, right, what I mean, P implies Q, contrapositive is negation Q, negation P, which is equal to, so you know very well. So all the things you know, and important statement, P implies Q cannot be equal to Q implies P. Try to understand. P implies Q, meaning is this. P double implies Q, means meaning is this. Right, important formulas I written, right, fine. Next one, this also everyone know, see the truth table, we discussed accordingly. Now come to first problem. This is the first problem, can you try this? This is the first problem, can you try this? This is the first problem, please try this. What is the converse of the following statement? I stay only if you go. I stay only if you go. Yeah, can you try this? What is the converse of the following statement? I stay only if you go. I stay only if you go. What is the converse? So this is the one problem, and one more problem also I made ready. Two problems I made ready. So please go ahead. What is the converse of the following statement? I stay only if you go. Yeah, I think you people done whatever possible. So let me give the answer. What is the converse of the following statement? I stay only if you go. Right? I stay only if you go. Yeah. So if you observe clearly, right? So only if you go, only if. Understand this, only if. So remember, you have to take care about these 12 points. I think it is the 12th point, right? So it is the 12th point. P only if Q. So which is nothing but P implies Q. Which is nothing but P implies Q. So I stay. I stay. Assume that I stay. Right? I stay is yes, assume. Only if you go. Assume that it is G. So this is going to be yes implies G. Only if. Important thing here is only if. Only if. Next one is asking which is the converse of the following statement. To this statement, what is the converse? Converse, you know, simply reverse it. Converse means simply reverse it. Okay, this is the thing. So now verify which options, right, will give the answer. Remember here, I stay if you go. I stay if you go. This is going to be yes. I stay, we given the name as yes. If you go, it's going to be G. So this will become Q if P. Q if P. So this is going to be, I think, G implies S. Check. This is, I think if anyone having small issue also, let me check here. I think fourth statement, Q if P. P implies Q can be written as Q if P. So it is a P implies Q. So it's going to be yes, right? G implies S. So I think this one same. I think it looked like A is the answer. Let's try B also. If I stay, then you go. I think it is a if P then Q. If P then Q. Yes here. G here. This is going to be S goes to G. If P then Q. So this is not the answer because we want G implies S. Let's go to the option C. If you don't go, then I don't stay. If you don't go, then I don't say. I think it's a if P then Q. But remember everyone, if you don't go means it is a negation. Then I don't stay. I don't stay. Negation S. So which will goes to if P then Q. Negation G implies negation S. This can be written as S goes to G. Check. I don't stay. If you don't go, then I don't say. I don't stay. So it's like option B, right? This is also fail. Let's go to option D. If I don't stay, then you go. If I don't stay, negation S, then you go. You go means G. So it's going to be negation S implies G. This can be written as negation G implies S. I think it's not. So answer is option A. It's a very tricky problem. But remember, it is came from these 12 points. It came from these 12 points. Remember everyone. Anyone having small doubt also? Sir, I have this doubt. You ask me, I will help you. Sir, I have this doubt. You ask me, I will help you. Check once before going to the next problem. Please check. Yeah, let's move to next problem. One problem we done. Let's try. Can you try yourself one more problem? I done one problem. Can you do one problem by yourself? Check everyone. I done one problem. Can you do by one problem by yourself? Check. Similar way you can try. Similar way you can try. Similar way you can try. If today is Monday, then tomorrow is Friday. Then find inverse of above statement. If today is Monday, then tomorrow is Friday. Then find the inverse of above statement. Today is Monday, then tomorrow is Friday. Then find inverse of above statement. So for the given statement, find inverse. Inverse, remember, find inverse for the above statement. If today is Monday, then tomorrow is Friday. Just keep whatever name you like. Assume it is A, assume it is B. So it's going to be A implies B. Okay. Then for this one, inverse. Inverse means everyone now negation you have to keep. Negation A implies negation B. Negation A implies negation B. Then find inverse of above statement. A implies B. What is the inverse? Inverse means what? Just keeping negation. So A implies negation A implies negation B, which will give something like that. We'll see now. So remember, A is today is Monday, right? So B is tomorrow is Friday. Today is Monday. Then tomorrow is Friday. Right? A implies B. So inverse is going to be negation A implies negation B. Okay, that's okay. Let's go to option A. Let's go to option. If today is Monday, then tomorrow is not Friday. Today is Monday. If today is Monday, what is the name? A. Okay. Then tomorrow is not Friday. Tomorrow is not Friday. Tomorrow is Friday is B, na? Not Friday means negation B. Then what is the inverse? Right? Inverse is negation. So negation A implies B. I think it's not. Let's go to B. Tomorrow is not Friday. Tomorrow is not Friday. Tomorrow is Friday B, na? Not Friday means negation B. Tomorrow is not Friday. Follow from today is not Monday. Today is not Monday, na? Today is not Monday. That is, I think, negation A. Negation A. Q follows from P. Q follows from P. So I think if you observe clearly, Q follows from P. It's going to be negation A implies negation B. I think exactly what you are looking for. So B. Exactly what you are looking for is that only. Next one. Today is not Monday. Let's check. Today is not Monday. A. Because of not Monday, na? Today is not Monday. So negation A is necessary condition for tomorrow is not Friday. So not. The negation B. Right? You know very well. Right? You know very well. Is necessary condition. So not sufficient. Necessary means Q. This is the Q. Q is the necessary condition for P. This is P. So this can be written as negation B implies negation A. So that is the reason it is false. Today is Monday. Today is Monday. I think A. Is sufficient condition for tomorrow is Friday. It is B. When you say sufficient, na? Sufficient means P. So I think it's going to be A implies B. P is the sufficient condition for Q. A implies. But I want negation A, negation P. So D is wrong. D is wrong. So I said today two problems. This problem, this problem. Let me know any objection, any doubt. Let me know any objection, any doubt. Check. Let's go to any objection and any doubt. Okay, that's perfect. I hope you don't have any problem. Let's move to next one. In tomorrow's class, we'll cover the remaining things. Tomorrow's class, we'll see the remaining things, right? So these are the batches. Tomorrow's class, we will see the remaining things. These are the batches. Regular course, right? Those people who are preparing for 2028, sorry, 27 people can join this, right? 2027 people go for regular batch. 2028 people, sorry, 2000. So, okay, let me write here. I think, yeah, perfect. Perfect. So 2027 people go for regular batch. 2028 people you can go to the foundation batch. Next one, 2026 people can go to test series, crash course, RIC course, right? Whatever you want, you can select, right? Fine. So you have, right? Combo courses also available, different courses also available. Different courses also available. You can utilize whatever way you want, right? Regular course, there is a 80% offer is going on, use it, right? EPT 610 EPT, you can use this course. This code you can use, you will get the 80% discount, right? You can go to the combo courses also, right? Whatever you wish, you can do it, right? These are our placement people, right? These are our placement students, right? Fine. In tomorrow's class, we'll see the right remaining things. 80% offer going on. If you are serious for the next year, right, you can start the preparation from now onwards. Okay, thank you. See you in the next class.